So feel free to take seats. music later, after party. All right, so good evening and welcome to the 12th edition of GraphQL Wrocław. It's nice to see you again this year. Right, so my name is Marcin Gębala and I'll be your host today. So we have two speakers today, actually. We will see how it goes because we had like this issue with our second speaker who suddenly realized 5 hours ago that Wrocław and Warsaw are different cities. But he's on the way and he should be here in like 30 minutes, 40 minutes, let's see. But we've prepared something in case we need to wait for him. Yeah, so let's hope he will make it. But we will start with our first speaker who will join us remotely. So our first speaker will be Benjie Gillam, who is community-funded open source maintainer. So for example, one of his projects is PostGraphQL, which is a project which allows you to build GraphQL APIs on top of Postgres database, which is pretty cool. He's also a member of the GraphQL Technical Steering Committee, so it's a good occasion to actually ask some questions to him about some like really nice insight from the core GraphQL team. And Benjie will tell us about new approach to GraphQL execution. So please welcome Benjie Gillam. Benjie, are you with us?
I'm with you. Thank you, everyone.
Great.
Hello.
Great. How's it going?
Yeah, not too bad, thanks. How's it going with you?
It's great, thanks. So start whenever you're ready.
Excellent. All right. Just a moment whilst I get all my ducks in a row, as it were. Shrink myself down into the bottom corner. So, hello, everyone. I'm Benjie, as previously mentioned, and I love GraphQL. I think GraphQL is awesome. It's made such a huge impact in the way that we build our client applications, our websites, our mobile apps, and more. It's shown us how we can be more efficient and get rid of this overfetching and underfetching, and really do things in a way that is highly optimized to the way that clients need. By minimizing the number of round trips and by having type safety, these both reduce the risk of something going wrong. And by handling partially successful results, it means that even if something goes wrong on the server, we can still render something useful to the user. The built-in documentation in GraphQL helps to increase productivity. And of course, by delivering the data in the shape that the client expects, we can minimize the amount of wrangling that needs to go on the client side. So all of this makes it much easier and faster to write our client applications, which makes it easier and faster to build things that our users love. GraphQL is amazing. But I have a confession to make. I hate resolvers. I've always hated resolvers. The GraphQL language is declarative. And yet, resolvers were not built to leverage this awesome capability. Instead, they turn execution into a procedural, layer by layer, field by field, item by item approach. To my mind, resolvers are very much a minimum viable product approach to execution. They're simple to understand and to specify, but they punt things like solving the N+1 problem into user space, requiring schema designers to remember to use abstractions such as DataLoader to achieve acceptable performance. And they rule out entire classes of optimization strategies. If you want to optimize what you're asking your business logic layer to do based on the incoming GraphQL query, For example, to only select certain fields from a database, or to tell your remote API to include additional resources that are needed, then you have to dabble with abstract syntax trees or similar look-ahead or transpilation complexities. It's unpleasant, and it's a lot of effort. Even people who put in this effort tend to only do so to a fairly superficial level, but the real efficiency gains would come from pushing this a bit further. All of this means that GraphQL is making our servers do more than they should need to, burning more CPU cycles, making more network calls, using more energy, putting more pressure on the environment, and it's not doing as much as it could be to save us money on our server bills or to reduce latency for our clients. In fact, my distaste for resolvers is actually why I joined the GraphQL working group in the first place back in 2018. The GraphQL specification seems to dictate that we must execute our operations using resolvers. It just seems so unnecessary. GraphQL being declarative language, why must we stipulate that we must execute it in a procedural manner? As I grew to learn the GraphQL specification, I realized, of course, that we don't stipulate that we must use resolvers at all. One paragraph right near the start of the GraphQL spec, which I must admit when I first read, I completely skipped over, went straight to the execution section, states, conformance requirements expressed as algorithms can be fulfilled by an implementation of this specification in any way, as long as the perceived result is equivalent. I.e., we stipulate that it must look like that's how it's executed, but that doesn't necessarily have to be what we actually do on the server side. So long as the observable result is the same, do whatever you want. But we still have resolvers. Resolvers are still the dominant way of executing GraphQL. Even in projects that delve a little deeper into optimizing backend queries, using tools such as my own GraphQL Pass Resolve Info module to look ahead and figure out what fields are being requested, we're still using resolvers. And the reasoning behind them is sound. The way they describe execution is correct. Without this definition, GraphQL could become more of a transfer format than an execution engine. Clients wouldn't be able to rely on the same assumptions, the assumptions that make things like normalized caching possible, because resolvers enforce the graph nature of GraphQL, where we traverse from node to node. The value of the node that we're on being dependent on neither where we came from nor where we're going to. And yet, this doesn't have to be the way that we actually execute operations. I've been battling this problem on and off for almost 6 years. I've tried many experiments over that time. I've really delved deep into the GraphQL specification to understand exactly why resolvers are specified, what they're protecting us from, and why they're declared in the way that they are. I tried to work within the constraints of GraphQL.js to solve this problem, and I've been reasonably successful, but it's always irked me that it just doesn't feel as ergonomic as it should be. The workarounds that I've come up with have been really clumsy and rigid. Admittedly, many of those solutions I came up with before I had the support of my many sponsors, so I couldn't really invest much time into their research. But thankfully, a lot of people have found the software that I write very helpful, and as my sponsorship has grown, thank you sponsors, the amount of time I have to invest in this problem has increased. About 2.5 years ago, I set out, very part-time, to solve this problem once and for all. But before we get into that, let's talk about my inspiration. For those of you who know me, you'll know that I love relational databases. Well, one particular relational database. Relational databases use SQL, which is a declarative language. It specifies to the server what data is required and the server decides how to execute it. And it can choose many different ways of executing that query. For example, it could factor in the presence of indexes or figure out how much data is expected so that it knows which type of operations to attempt to do. This is called query planning. Modern Postgres even has such things as genetic algorithms to help choose the very best possible execution plan in as little time as possible. And things like just-in-time compilation, which will compile your SQL expressions down to machine code so that they can be executed in the most efficient way possible. Now, GraphQL is declarative too. So we have resolvers. We don't have generic execution planning for GraphQL. But it's not fair to say that we have nothing. Loads of people have felt this pain. So now we have specialized planners such as the GraphQL to GraphQL planner found in Apollo Federation. Or we have optimization of the GraphQL internals in GraphQL JIT. We also have ways of optimizing particular patterns, such as projections in Hot Chocolate, or the GraphQL to SQL transpilation within Hasura. But we don't have a powerful, general-purpose query planning system that takes a holistic approach and allows advanced optimizations no matter what your underlying business logic may be, at least until now. So, after that really long introduction, I'm here today to say, step aside, resolvers. There's a new way to execute any GraphQL operation. The working title for this new project is GraphFast, and it works by taking your GraphQL operation and compiling it into an execution and output plan. Now, the output plan is a straightforward mapping from the data that we retrieve through the execution phase to the GraphQL result that we're going to output for the user. So we'll skip over that. Most of what we care about is the execution plan. We build the execution plan by mostly following the execution algorithm that is in the GraphQL specification. However, we do this before we actually execute. So we're not dealing with the concrete data that we would be in the GraphQL specification. We're instead dealing with what we call steps that represent this future data. When it comes time to execute, a step is quite similar to a data loader in that it accepts a list of inputs and it returns a list of outputs. So batching is built into the very heart of GraphFast. Whereas a field in a traditional GraphQL schema would have a resolver, in GraphFast it would have a plan resolver. The plan resolver has similar looking code as you might be able to see from a glance, don't bother reading it in detail, but again, rather than dealing with concrete runtime data, it's dealing with this future data, these steps, which we represent with a dollar symbol in the code on the right. So when we see a GraphQL operation, such as this one, we can walk through the selection sets and we call the relevant plan resolvers at each stage. And out of that, we can build a plan diagram like this one that expresses exactly what needs to happen. Now, this plan diagram is not the final thing that will be executed. This is just our first draft. The GraphFast system will go through each step in the plan diagram and give it a chance to deduplicate itself, to optimize itself, and to finalize itself. These are the three main lifecycle methods that the steps may implement. Deduplication allows for similar steps to be amalgamated to simplify our plan diagrams. Optimization is the main phase, the most critical one to performance, and it allows steps of the same family to communicate with each other and pass information between one another. For example, if we're dealing with the Stripe API, we might have a GraphQL request that has a field in it that fetches the customer from Stripe. And then maybe the user has also requested a child field on that that fetches the subscriptions for that customer, and then various fields below that. Now, when the step that's responsible for getting the subscriptions is being optimized, and remember this is before we execute, it could determine that its grandparent is pulling data from a Stripe customer and thus tell the customer step to fetch the subscriptions at the same time. Stripe has a feature called expanding for this. This would mean that the subscriptions fetching step is now redundant. So, as a last action in Optimize, it can replace itself with a step that extracts the relevant data from the customer response. This way, we now only need one round trip to Stripe to get all the information that we require for our GraphQL operation. Finally, we have the finalize method. This is typically unused for most steps, but it gives the step a chance to prepare for execution, to do something that only needs to be done once. For example, it might be used to compile an optimized JavaScript function to execute its action more efficiently, or it might be used to prepare a final SQL or GraphQL query text ready to be sent multiple times in the future. Now, importantly, steps are designed to be something that you can implement yourself, much like you would with a DataLoader callback. They're a little more powerful than DataLoader, and they have these optional lifecycle methods that we've discussed. But in the simplest case, all they need is an execute method that takes a list of values and returns a list of values in the same way that a DataLoader callback does. We also have a number of optimized pre-built steps that you can use to handle common concerns, including things like load one for batch loading remote resources similar to DataLoader, or each for mapping over lists, or access for accessing properties from objects. And we're building out more optimized steps for dealing with particular concerns, for example, issuing HTTP requests, or sending GraphQL queries, or talking to databases. Ultimately, our intent is to use these steps to pass additional information to your business logic layer, no matter what it is, so that it can execute its tasks more efficiently. So, just like GraphQL helps to eliminate the over and under fetching on the client side, GraphFast helps you to eliminate it on the server side. For example, if your business logic is implemented with an ORM or something like that, you can use this additional information to perform selective eager loading to reduce the number of database round trips that you need to make. If your business logic is from an HTTP API, you could use this contextual information to dictate which parameters to pass, better controlling the data that you're retrieving, reducing the server load and the network traffic. And since GraphFast is designed around the concept of batching, you never need to think about the N+1 problem again. It's solved for you out of the box by virtue of just how the system works. Now, just like with GraphQL resolvers, GraphFast plan resolvers are intended to be short and only express what is necessary to communicate between GraphQL and your business logic. And despite their pleasant ergonomics, they unlock much greater efficiency and performance than resolvers can. GraphFast has been built from the ground up to support all of the features of modern GraphQL: queries, mutations, subscriptions, polymorphism, and even cutting-edge technology such as stream and defer. And it's backwards compatible with existing GraphQL schemas, so you can use GraphFast to execute requests against an existing resolver-based schema, and then migrate to plan resolvers on a field-by-field basis. And if you're already using data loaders, then migrating to using GraphFast plans should be quite straightforward. We're hoping to release an open source version in the next few months. It will be under the MIT license, as is all of my open source work. To be notified when we're ready for that release, please enter your email address at graphfast.org and we'll send out a mailing list shot when the time comes. If you'd like to help me to continue to invest time in projects like this, then please consider sponsoring me on GitHub sponsors. And you may even get early access. Feel free to reach out to me with any questions. Thank you for your time, and I hope you're as excited about the future of GraphQL as I am.
Right. Thank you, Benji. Great talk, and it looks very interesting. So let's see if we have any questions. Yeah, I'll just add that we have really cool merch T-shirts from GraphQL Wroclaw. So for every question, we give one T-shirt. Yeah, nice. I know. So, are there any questions? Come on, don't be shy. Yeah.
Free T-shirt. I just for the T-shirt. Yeah, it looks amazing. I was wondering. So it seems like the resolvers are essentially lazy, right? So every function is not actually querying the data. It just creates like a lazy function that gets queried at the very end, right?
It's a little bit more complex than that. So it builds out these steps, which are, so that code, those plan resolvers, that code doesn't run at execution time. It only runs once at planning time to figure out what steps are involved. And then after that, then the steps themselves execute, which is different code.
Yeah. So this is what I mean. Like essentially, these are just a bunch of lazy objects. And what happens if you resolve something and you actually in that chain you actually need the data of of the parent to be able to resolve the children, because the data is not being fetched at that moment, and you have that dependency that you actually need to know. What would be this? How would the strategy look like then?
Okay, so I think what you're asking is if you need to branch during the plan. So
yeah,
if based on the data you fetched, you might take one action or another. There are a few ways that may happen. So for example, polymorphism is a good example of that. If you fetched a user, then you might need to do user things. If you fetched a cat, you need to do cat things. So that's all baked into the system. However, what you should probably keep in mind is that this isn't intended to replace your business logic. This is built on top of your business logic in the same way that resolvers should be in GraphQL. So it's only meant to be a thin layer. All of your branching should really be mostly in your business logic, and it shouldn't generally be a concern. There are, however, things where you might want to branch based on the user input to your query. So things like input arguments. You might want to, for example, filter the a field to say only include the users and don't include the cats, in which case the SQL queries or whatever you've got on your backend is going to be different. And we do allow you to branch the plan based on user input. And that's not done as like a exact value match. It's done as a kind of a broad match, as broad as you can allow it to be, and still meet your requirements. So there is branching based on user input.
Excellent, thank you.
Thank you. You earned a T-shirt. So, any other questions?
Sorry. This optimization of the queries, it happened on a SQL level, or just like a higher level in JavaScript, in like when it analyzes what you're trying to do, but like how would it know that it need to make like one query to SQL or multiple?
Okay, so the steps themselves, the step classes, so you can think of them a little bit like data loaders. They have that logic in them. GraphQL doesn't do that for you. All it does is it tells them to do it. So each of those steps, it says, it's your turn to optimize. You go do your thing now. So you have effectively like families of steps. We're building some for you. So like we've got some that are highly optimized for talking with Postgres, of course, because of PostGraphQL. And there's things like the load one that you can use in a data loader like sense. But when you've got your own business logic, you can build your own steps that have their own optimization strategies that understand your logic and what your kind of inlining is. And one of the best things about this is you don't need to add those optimizations at the very start. Instead, you can just build out with a basic set of steps that just do the work. And when you want to later optimize them, you just update the step definitions. You don't have to update your schema code or your plan resolvers, just the steps themselves where they have those lifecycle methods. And you can give them the ability to talk to each other and to make decisions. So for example, we talked about the Stripe example in this. That would be something specific to Stripe. So it would probably be a family of Stripe-related steps.
Okay, then I need to build, like, based on my application, I need to build the steps. And then in these steps, I need to build a family of steps. And then the optimizer would know how to optimize my steps based on how I define them.
Yeah, you define your own optimization strategy for each step. Or you don't, you know, that it's optional. At a baseline, it will be the same as just having a data loader. But if you want to implement optimization over it, then you can unlock this greater ability. And I suspect what we'll see is a lot of like user contributed steps. So for example, I hope that we'll see like a Stripe family of steps that people can use if they need to communicate with Stripe and things like that.
Thank you. Any other questions? If not, then I have one. Like, I was wondering how it works, like when you want to integrate GraphFast with your server. So is this actually behaving as a GraphQL server? So you use that instead of the server you use normally, or is this some kind of middleware or a library that you plug into your existing code? Like, yeah.
Great question. So GraphFast at the moment is implemented in JavaScript. My intention is that it will be implemented in many languages in the same way that GraphQL is. I would like to see resolvers go across the board. But at the moment, it's effectively a replacement for the execute method that we have inside of GraphQL.js. So GraphQL.js has a GraphQL method. What that GraphQL method does is it passes the query, then it validates the query, and then it executes the query. Mm-hmm. So we are just, GraphFast is a replacement just for execute.
All right. Yeah, I was wondering actually about the support in other languages. For example, we use Python and Graphene. So I suppose that in the future you would like release some kind of specification of how is that built, and then, for example, the community could build Python support for that, which we could use in Python frameworks, for example.
Yeah, absolutely. I'd love to do that. And I think one of the great things about this is because it only really covers the execution section, it should be hopefully relatively easy for other languages to adopt. They don't need to redo all of their validation and various other things. It's literally just the execute section. And I'm really interested to see at some point how this will work with other languages. So for example, Python, I know you've got things like twisted Python, right? I think, which handles like asynchronous, there's like promises and stuff like JavaScript does. Yes. But Python itself is generally a synchronous language. And I think GraphFast would actually lend itself really nicely because of the way that it does batching, and it doesn't rely on these kind of parallel promises that the GraphQL spec itself kind of does. It should make support for those kind of languages even easier, I hope.
Yeah, really looking forward to having support for that in Python. So maybe one last question, since you are part of the GraphQL working group, maybe you can say something like a little about it, like what you are like working on right now, what's like maybe the main focus of the working group right now. Is there any specific feature that you are focused on? I know this will be part of Michael's talk, but maybe there is something that you are personally involved or happy about, like some new feature coming to GraphQL.
Okay, well, I'll cover, so as to not steal too much of Michael's thunder, I'll cover two things. One is that the bulk of work, I would say at the moment, like the busiest, most active part is on the stream and defer directives. Defer particularly, but also stream. We're doing a lot of work, and we're actually doing weekly meetups now to discuss those features to try and help get this over the line so that we can actually merge it into the spec. We've actually got quite a number of experimental implementations out there, but because we keep changing stream and defer itself, like it's not ready to go into the main master spec just yet, but we're getting quite close now, I think. As for things that I'm involved with that, but only in a peripheral sense. I'm also the author of the one-of RFC. So one-of is a directive that you could add to input objects to say exactly one of these keys should be set and must be non-null. What this is really saying is it's giving you a way to do polymorphism on input, which we don't really have currently in GraphQL. So we spent a lot of time, we've actually been talking about this for almost 3 years now, I think, talking about the various different ways that we could introduce polymorphism in the input of GraphQL. And there have been a lot of approaches, some of them that look a lot more like the interfaces and unions you may be familiar with from the GraphQL spec itself. But it turns out that they're not always the best match, and actually a different approach for polymorphism on input might make more sense. So I wrote the one-off proposal and pushed it a fair way along, and it is currently the favorite. But after doing that, I came up with another idea, which I'm calling the tagged type. And that, no, not, it's a different one. I've forgotten its name. But that one is thinking more in terms of solving this problem, but also solving some other problems. It's called struct, my apologies. So struct is giving the ability to have like structured leaf nodes in GraphQL. So where you request a leaf, you normally receive the whole thing, like an int or a float or a string, something like that. You receive the whole thing. This is giving you the ability to have a leaf that is structured. So you can just say, I want this thing, and you get the entire document come through. It could be like a prose mirror document or something like that. That is one that I am exploring, and it has meant that I've put one-of on hold a little bit because I want to explore the struct type a little bit more first before we commit to one or the other. Because one of the things about the GraphQL spec is we want it to keep working, you know, indefinitely into the future. And we don't really want to say like, oh yeah, we introduced like 8 different forms of polymorphism, because that's going to be a bit overwhelming. So we'd like to get it right first time if we can.
Sounds really nice. So are we going to just add that to the spec, or is it like the plan to release some GraphQL v2 or something like that? Or are those new features just rolled out in the spec and then like server maintainers, it's like their turn to implement that? Is that like how it works?
Yeah, so everything we put into the spec at the moment is backwards compatible unless there is a really, really good reason that it cannot be, and where, you know, very few people would be affected by these changes in a negative fashion. So everything is additive in the same way that when you write your GraphQL schema, you should make additive changes to it so that it still supports all of your older clients. We want to support all of the GraphQL clients across the world in, you know, Relay and Apollo and Urkel, but also all of the little like fetches that you've got in your shell scripts, all that stuff. So yeah, we're very, very careful, and this would just go out as a normal feature in GraphQL, so it wouldn't be any kind of major version bump. We don't even have the concept of like a major version bump. We do have releases, but they're more just like a chance to announce, hey, we've done these things. Really, you've been able to use them for like 6 months, 12 months before we do one, really.
Okay, cool. I don't have any more questions. Anyone else, maybe? If no, then thanks a lot, Benjie. It was great having you. A lot of good stuff here, so thanks a lot.
Thanks, everyone.
All right, since we are still waiting for our second speaker, we have prepared like very last minute like lightning talk about like the usage of GraphQL that we are doing at Sailor. So like Michael should arrive in like 15 minutes or so. And then after my lightning talk, or after this demo, we will do a short break. And then we will go with Michael's talk. So yeah, since we are still waiting, I'd like to like show one thing. Can I share my, right. So actually we had on one of the previous editions, we had talk about like this topic about subscription webhooks, but it was like very early version, and now a year later we have it actually working, and we've built UI for this. So I wanted to show you what we've built and how we use GraphQL to define webhook payloads. And that will be based on Sailor example. So yeah, I think I can skip this. You know me already. I work at Sailor Commerce, where I lead the backend team that maintains the GraphQL API. And just to give you the idea what Sailor is, it's an open source GraphQL first headless e-commerce platform. A lot of buzzwords, I know, but it's all true. So e-commerce platform, I think you are all familiar with this. It's just the software that does e-commerce, such as Shopify, Magento, etc. Open source, it's pretty obvious. Like all of the things we build are basically open source. GraphQL first means that the API that we have, and like since the very beginning, we always had the GraphQL API, and we are very focused on this. This is mainly how you interact with the platform. And headless means that it comes without any storefront, which was kind of obvious in the previous e-commerce platforms that were earlier, that they were providing some front end that you were using, and in headless it gives you more ability to integrate with other systems. Yeah, and just to give you an idea, that's how the dashboard looks in Sailor. This is where you manage orders. This is where you process your order lines, and yeah, basically e-commerce, like one of the main features of e-commerce. And what as I said, because it's headless, it means that we are really focused on making it easy to integrate with other systems, which is often the case in e-commerce. Like you always have some payment providers you need to integrate with, like shipping providers, tax APIs. So you don't build this stuff yourself, but instead you integrate with other systems. And often your customers also use some systems they want to keep using. So that's why extensibility is very important for us when building Sailor. And to achieve extensibility, we use webhooks. So I think most of you are should be familiar with webhooks. Now most of web platforms supports webhooks. So this is basically a way to communicate with external services. So we have Sailor, which is one service, and we have different services which we call apps, and they can get notified about stuff that happens in Sailor through webhooks. And at the same time, they can also fetch data from Sailor through GraphQL API. So this is the two-way communication between different systems, basically. And how webhooks are usually implemented is on this example, that there is an event happening, like in this case, order created, which means there is a new order placed in the shop. And then usually there is a huge JSON payload delivered to each app that listens to your webhooks. So you can register to different apps can register to those webhooks, and they will get notified about every new order. So the thing is that this JSON payload is usually predefined and fixed structure, and you don't have any way to decide what you want to get actually. Yeah, and why is this a problem? So in some cases you can get too much or too little data. If you are getting too much data, then it's just basically, affecting the bandwidth and transferring simply. It may be slower actually. If you are getting too little data, it means that you may have additional API calls to fetch the data that you are missing to perform something. Also, in our case, because we had this implementation before, it meant that we were maintaining this extra layer that was only responsible for generating those JSON payloads, and at the same time we had entire GraphQL layer. So we have two places in code that does similar thing, because in GraphQL the response is JSON. in webhook, the payload is also JSON, but we have two ways to build it. So we have to maintain those two ways, which is not perfect. Fortunately, we have GraphQL, and we can actually reuse GraphQL in the communication between apps in the backend. So what we've implemented is a solution where you define those queries, like subscription queries, in order to define what data you want to get. Right, so like we don't use this subscription thing that you have in GraphQL for real time. It's not real time. It's just the subscription syntax, because subscriptions are meant to represent events, basically. So let's see what we have here. That's the name of the event. We have a lot of these, and it like tells us what event we want to subscribe. In this case, order created, just as on the example before. And then we have the body of the like definition. So in this case, we are getting order data, and for this order, we are getting its number and user email. I skipped this one. That's actually pretty internal, but we implemented this by defining this interface. It's called event, and it provides a set of fields that are available in every event, such as date of issue, version of sailor, information about the recipient, and stuff like this. And in GraphQL, you can use interfaces to like have those common fields and build specific implementations of this interface, like on the right. This is one of the events. And we have many of these. They are all implementing this event interface. And that's the example that we saw previously. And for this subscription, we would get this response in webhook payload. This is the way we use in API to define those subscriptions. So basically, each webhook is an entity in database, and it has this query field. So whenever you create a new webhook or you want to update it, you just provide this subscription syntax in here. It gets saved in the database, and whenever there is a new event happening in Sailor, we just run this subscription against our GraphQL API. So as a result, we are basically having the same benefits of GraphQL that we have in like communication between backend and frontend. So there is less data transferred because we are only getting the data that we need. We are reusing the same GraphQL schema, which is great. So it means that we don't have to maintain those two layers. We just focus on building GraphQL, and we use that both for webhooks and for the API, which is really great. We also get improved performance with this, because like the schema itself just use data loaders, which make sure that everything is optimized and not making too many database queries. So we get that as well. We can use deprecation directives, which means that we can say that the total field is deprecated and will be removed in some of the future versions, and now you have to use a different field. It's not like there is no way to achieve that in traditional webhooks, where you just cannot remove a field because some integration might be using it. In here, we can just deprecate it, so someone who maintains those webhooks can see that this field is deprecated. And as a bonus, we get auto-completion, which is really nice and makes it easy to build those queries. And to show you how it works, we have a small demo, which is really like also last minute, because now like it's basically being built right now, but it works. And let's see, actually. So yeah, this is Sailor dashboard, and this is where we define our webhooks. So in this example, I have one webhook. It's called product updated. So as you can expect, it will be called whenever there is an update to a product. Here we have some product. And what else? We will be using this little tool called webhook.site. Really recommend that if you are working with webhooks. It's a very convenient way of testing payloads. It's just a tool that gives you this unique URL, like this one, and it just receives JSON data. So you can use that for any case where you just need to provide some URL and send some payload just to test it. So it's really great in this case. So I'll be using this one. So this is my target URL. So any update to a product would send a payload to this URL. So what we have here, that's what we are building right now. It's the GraphQL playground that is embedded in our dashboard, and this allows you to build those subscription queries. So as I said, you can get this, auto-completion. So you can easily type the queries and decide what data you want to get. So let's say that for every product update, I want to get the product name and its category and its name. Let's say that I want to get the ID. Yeah. Now if I save this and make some update here and save this one. And here we get the payload. So as you can see, we are getting exactly the data that we asked for in the subscription. If we change this to, for example, ask for, I don't know, metadata. Let's say we want to get metadata, save this. And again, if we trigger some update here, we are getting, in this case it's empty, but as you can see, the key is already present in the payload. So yeah, that's how it works. And what is also cool and pretty new feature is that we are actually building a dry run, which allows you to test those subscriptions without actually sending any data over the network. So it just uses our GraphQL schema to get the data. So let's say that we want to emulate the product updated event. We click this button, and here we can pick some product for which we would emulate the event. Let's say it's this one. And here we are getting the response that we would get in our integrations. So this is a great way to test webhooks. Yeah. I think that's it, actually. Lastly, yeah, if you like it and if you didn't know Sailor before, you can check this out. As I said, everything we do is open source, so if you are curious how it works, it's out there. There are also some integrations. For example, we have integration with Slack that uses this solution. So it gives you notification about new orders on Slack. So yeah, if you are curious, you can check this out. Yeah, are there any questions?
Can you subscribe to multiple events at once? Yes. And then only the first one that would happen, or you would get each of them depending
Once you start ticking the boxes, the query is actually auto-completed for you. So yeah, maybe scroll. You see, there's a new one being added automatically.
And then on a webhook side, you would decide what to do depending on the payload.
Yeah, so you would have to branch, through the event depending on the type that you receive. Yeah.
And you can also see what the clients are using. You can see what type of subscriptions they are making, and you can optimize the things that are slow or things like this. You could introspect what they are using, basically.
Yeah.
Thank you.
I think maybe one extra point for this one, that one of the problems that it solves is the also permissions. No, what I'm about to say is that, in the context of sometimes GDPR and sharing data with external services, is that in a traditional sense, you receive this payload and there's so much information about customer and the the address and so on and so on. And sometimes you don't want to overshare. So this is in a way a way to control data access in event-driven architecture. Exactly. Yeah.
Yeah.
So sorry to hijack your presentation.
No worries. We are here, to exchange knowledge. So there is a question behind you.
Hi, I really like the way that the subscriptions works, but I have a question. Do you have an option to get any event that will come to your system?
We had this, and we still have, but we actually want to remove this because there is a lot of events, and actually the app that listens to the events would be flooded with a lot of stuff. So we think that it's not a perfect solution. Instead, you should explicitly decide what events you want to subscribe to.
Okay, and the other question is, have you considered using Event Bridge for events for AWS customers? I think it would be a very good one.
I don't know, actually. It's currently webhooks are, we are using just a worker, external worker that is responsible for sending that in cloud as well, I think. But probably we could optimize this by using some dedicated solution. Like for our webhooks, you can not only use HTTP, you can only subscribe to queues, for example, but yeah, I'm not sure if that would work with subscriptions and if we support that currently. But maybe yes, it's maybe something we should.
No, Event Bridge is different. We can talk after about it. But no, and is there an option to, for example, rerun your events from the past?
We have API that records every webhook attempt. So when there is, and we actually don't store any success attempts because we assume that most of them are success, and also if we store them, there would be really huge amount of data stored in the database, and you are usually interested in those that fails. So we store those. So each attempt has its own ID. We also store the payload. We know what was the query. So technically you can retry them, but I think we cannot retry stuff from the past because the database changed already. So you could retry the event, but you would get different results maybe. But yeah, we record them and you can retry them.
So you are sending them only once after the change, so there is no retry policy?
There is retry. We are trying to send each one, I think 5 times with different intervals.
Mm-hmm.
If that fails, it's just recorded in the system as failed attempt, and then you have to decide. Maybe it's something broken with your integration. But what we are also building is a UI which will allow you to inspect this just from Sailor. Now you can query that from API, but there will be UI that allows you to basically track all the data that gets sent between apps and Sailor.
Okay, and one more, because you are using the syntax from GraphQL for subscriptions.
Yeah.
So you're using it underneath, or is it just a way to make developers' life easier?
It's just a way to express, to define the event structure. It's not using these GraphQL subscriptions, those real-time ones underneath, which also could be implemented in the future. Currently, we just didn't, never think about this. Also, our framework needs an upgrade because it doesn't support async stuff currently. We would have to use some external, I don't know, server for that. I don't know, but it's. I think it's possible in the future.
Okay, thanks.
Thank you. I think we can have a short break. I see that Michael is here, so we will make it with the third speaker, which is great. So let's see you in 10 minutes. And prepare for this amazing talk.
Drinking beers instead of... Yes, that's good. And they are relaxed.
Okay, so let us begin with the second talk, which is the third talk actually. So Michael made it to Wrocław. I'm really happy that, yeah. Yeah, so our next speaker is Michael Staib, who is also part of the GraphQL Technical Steering Committee and also author of Hot Chocolate and other frameworks with cool names such as Strawberry Shake or Green Donut. Yeah. And he will tell us about new features that are coming to the GraphQL specification. So please welcome Michael Staib.
Yeah, hi everyone. So after picking the wrong city in Poland, I finally arrived here after 4 hours in the car. But okay, it worked out. So thanks to Mirami to get me from Warsaw to Wrocław, which looks very similar if you look at it from yeah, almost the same. So let's talk about what's next in GraphQL. Or building modern applications with future GraphQL. How the new GraphQL stuff will change how we will build applications in future. Or maybe if you are adventurous, feeling adventurous, you can start with that even today. But let's have a look at that. So when I started building that talk about future of GraphQL and all the nice things we are working on, I actually did it because a lot of people were talking about GraphQL has stagnated or why is GraphQL not moving. And actually the idea of this talk is also that you get the feeling what we are actually doing behind the scenes to push it to the next level. And if we look at GraphQL at the moment from the consumer perspective, the last biggest change that we did was subscriptions. But Lee Byron already, if you remember a talk from, I think it was React Europe, already outlined actually all the cool stuff we are working at the moment on, like live queries, defer and stream, and other cool things. So when we look at GraphQL, and this is probably the simplest GraphQL query you could write. It's essentially asking our server for the currently signed in user and the name. And GraphQL actually was designed to put us in control of how we get data. So if we send this query to our GraphQL server, we get something that closely aligns our request. And Facebook designed that actually with the aspect of mobile applications and slow networks. So this is the basic stuff, just to get us slowly in. So GraphQL mainly was concerned with network payload in the past. But it's also great, and was also great then, with relations, drilling into relations of data, fetching other stuff. But what can happen here is that we are actually drilling in costly connections. So friends could come from a different database. We might have to aggregate database calls or even REST calls behind the scenes. Before we get into what the problems are here, let me introduce one other concept, and if you're into GraphQL, you know that, it's fragments. And the potential of a fragment is essentially that we talk about data components. But at the current version of GraphQL, it's more like a data contract. But it's a data contract for our UI components. So I like to see them as a data component. So if we look from a relay perspective, for instance, on top of this, or into this, is that these data contracts actually allow us to collocate UI components and data contracts. So if we look at modern applications, and this is a bit of an example of a modern applications for me, let's have a look actually at it, then we are composing a lot of these components. And what the beauty is then with GraphQL, and that's for what they have designed it, is no matter what I do in this application, it's actually just one data fetch. For instance, I loaded this application, so it's one GraphQL call. If I drill into, for instance, here the Bitcoin, it's just another GraphQL call. And if I, for instance, switch something here, it's just one more GraphQL call. So that's a typical thing that we have with GraphQL. So what else is here modern is that actually everything lives. So you can see that here my data components live, they update constantly. And if I go back to my overview, it's the same thing. Everything lives here, the data lives. But also this application is actually very reactive. So it doesn't take a lot to move around here. And as I said, everything has one data call. So let me go back to the slides. So GraphQL in the beginning was optimized of reduced network calls. So I said that before. But this has a problem that we put everything in one network call, and we want to optimize for this one network call, but it gets maybe really slow because we didn't optimize for minimizing the time to the important data. So if you look at my application that I have here, you can see there are a lot of elements here. For instance, we have here a graph for the Bitcoin, and the graph actually is an expensive thing. And if I swipe to the side here, you can see I have a lot of other graphs here with more data. But actually, when I first load this application, I only see this first graph. So in order to optimize this application, we can optimize now the time to get the first data. And with that, empower our consumer of our API, the front-end developer most certainly, to really build this awesome experience here and get a fast application. So let me just dive into our GraphQL tool here. And the best feature of this GraphQL tool is actually that we can, okay. No, okay, so let's dive into our GraphQL IDE a bit, and this is actually the query that powers our front end there. So this is how we fetch the assets. So if I run that, you can see it takes a bit because there's a REST service involved, and it takes like 1 second to get the data here. So now with defer and stream is one of the first features I want to show you. I can now optimize my data call and say, for instance, actually, I don't want all these nodes because I wanted the Bitcoin for the Bitcoin graph that I have. That I want to have first. So I stream the data here, but I say I want the first entry I want to have immediately. So that's my initial count. And after that, give me all the rest of the data. But I already know that this part actually, to get the price points, you can see that's a lot of data I have here, is actually the expensive part. So I'm going to add a second thing here, and that is the defer directive. So I'm saying defer this part and stream the nodes. And then I can rerun my query here, and you can see the first data arrives now in 270 milliseconds. So suddenly my application is really fast. And in my GraphQL IDE here, I can drill into actually the patches and look what's going on the wire. So I can see that now I get the first price first here and adjust that, but then it tells me there's more. And I could go through here, for instance, to the 13th part, and then you can see that other data, like the graph data, is really arriving. So stream and defer really allow me now for modern applications to define in a single query, a single HTTP post request that I do. It's not WebSockets or something. It's working over HTTP 1, but I have this new awesome experience. So, and if we look at our component here that makes this all possible, it's actually for the developer now, just adding this little thing here, and you have a complete new experience. And this especially if you power it with something like suspense in React. Okay, but with great power comes great responsibility, and that's a part where I tell you why it takes so long to get it in, because Lee showed us this feature already in a I would say, keynote representation in 2016, so 6 years ago. So why did it take us so long to make it work? So this is just the last, I would say, like we are talking about this problem the last 2 weeks in the working group, because so we looked at the feature. This is really a nice query here. Maybe look at the fragmentized version. It's essentially the same that I had before. And now maybe a developer is sitting in his components and he thinks, oh, my friends all did this defer and stream stuff above in their components. It works now faster. So let me optimize also my defer here. So I'm adding a stream here. And then we execute that query. And suddenly, you can see already my UI freezes. And our optimized query now takes a lot longer. You can see it's taking forever. And when we look at our patches, we suddenly have over 3,600 patches. Because if you don't do it right, actually defer can DDoS your server very easily. Now I can just define small queries against your nice GraphQL server and kill it very, very quickly. So the current discussions on this is to defragmentize, to merge essentially these defers and get rid of defers that may be unintentional. Because what you want to have is more like a deferrable. So you want to tell the server, ideally, I get that later, but maybe there's something not so good with it, then the server should optimize it. Because the main effect that I want to have is a fluent UI. And that is where we should talk about fragment modularity. And that's another feature, but ties very nicely into our problem here. So when we talk about GraphQL in present, it's mostly about minimizing network responses and optimizing these network requests. So we want to have reliable data fetching that is fast over mobile networks. That was the original intention. But when we look at our fragment structures here, for instance, then what the GraphQL server originally does is defragmentize. So essentially, if we look at these fragments here, when the GraphQL server essentially optimize this query, it looks more like this. So the first thing a GraphQL server is doing is throwing out all these fragments and merging all the fields so that we don't send over unnecessary information. But with defer and stream, we are suddenly having like deduplication of data. And if we fixed that problem in the defer spec, we would lead essentially to the same behavior where we reduce these deduplications, but then there is a problem for the client developer to know if the data for a certain component really arrived. So, ideally, this could be solved with something like a label, and we tried that actually. It didn't work out, because if we got rid of the defer because we optimize it, then we also don't get the label sent over the network transport. So what we ideally want to do, and that's not only about defer and stream, is reason about fragments in isolation. So if you think more about fragments, and I told you the term of a fragment or a data component, we actually want to use it like a component. If you think about this price details fragment, maybe we want to reason about it in our client code that it's something awaitable, where I can say, okay, I have the asset, now I await the price details fragment. And at some point, I will get that. But because we defragmentize in the server, we don't have a sense of a component. Maybe also, I want to have a check more like this in line, but again, I want to have the structure of a fragment in my client application. So a trick that actually somebody at Facebook came up with is to misuse the dunder type name field and then alias it. And then we actually would get an information in our payload that a certain fragment arrived. We could also formalize that as metadata. We thought a bit about an isFulfilled field here, which you could alias, and if you see that, then you know a fragment arrived at your component. But actually, it's not so nice because it's a bit hacky. It is more workaround. So ideally, we want something that aligns with our response shape. And this goes more into a data component, because when we could alias our spreads here, like our price detail fragment, for instance, we could introduce also a different response shape, where we have now suddenly our fragment as its own shape. So now we are closer to our data component. And that could even be taken further, and we're thinking about something like this, where we actually now are very close to a data component, where a fragment actually can have parameters, arguments that you can pass into. And then you could maybe get two prices in the one component. Now it's usable in a very different way. And because of this new transport shape or response shape, we suddenly could reason about fragments. Meaning, if we optimized the differs and kicked out a lot of the unnecessary or unintended differs, we still could reason about what data arrived. And let's have a look a bit on the transport side. So when we look at the defer transport, we can see the typical GraphQL response here. There's the data shape, where we maybe get the initial data here, maybe users and the me field. And then we get this new pending section, which tells us which data is really deferred. So initially, when we looked at the patches in the beginning of my talk, we thought that we didn't have this pending because we initially didn't need it. But now, when we optimize this thing, we suddenly need to tell the client what we have deferred or what is not being deferred. So in this instance, the server tells us there's coming more data, and this data is in a certain path. And then in consecutive data, we can refer to that and get the incremental patches. So you can see these little nuances that actually introduce difficulties that you often see very late and take long to fix. So introducing these big shifts in GraphQL actually takes a lot of detail work, a lot of implementation that you have to try out. For instance, Hot Chocolate or GraphQL JS implement all these features already today. So you could use them, but you also would have these risks that I showed you, where unintentionally you have these response explosions. So let's shift gears a bit, and there's another cool feature for modern applications, and that is client-controlled nullability. So client-controlled nullability, let me explain it this way. If we look at other modern app characteristics, we can talk also about like strong contracts. Like GraphQL is so nice because we have these nice strong contracts, and these enable static typing on our clients. So we call that type emission. Essentially, we generate from our GraphQL types, from our queries, some types for our clients. And it's nice to use that. But the reality is that a lot of fields are nullable. And that is because there is something called non-null propagation. Who here knows what non-null propagation is? Okay, it's one of the basic concepts actually in GraphQL. And, but a lot of users have the same conception. What is non-null propagation? So in GraphQL, let's say price here has an error. So what the GraphQL execution engine will do is set price null. So if all types are nullable, because they are normally nullable, that would mean that the moment this becomes null is that we cannot send a valid response to the user anymore. So what the GraphQL engine does is essentially null the next parent. So we're deleting nodes here. And nodes cannot be null, so we are deleting assets. Assets cannot be null, so the whole result is being deleted, and we just have an error here. And that's why most schema developers actually choose to make these connection nodes, so composite types, nullable. But from a client aspect, this is really rubbish, because now I have to write all these shitty null checks. So what this new feature of client-controlled nullability is about is giving you the power to introduce non-null boundaries, or as I call them, error boundaries. Let me show you. So all this stuff is actually already implemented in Hot Chocolate and many more features. So if you want to try them out, you are welcome to learn some .NET. Give me a second. Let me just get rid of these. And so let's say we have this nice data set here where I fetch all these nice cryptocurrencies. For instance, the Bitcoin, and the Bitcoin has a white paper, and actually there are a lot of them, but only one has a null here, and this can be nullable. So with non-null, with client-controlled nullability, I can now change that. I could say, actually, white paper, my client component doesn't allow null. So I'm saying this is non-nullable. The GraphQL IDE actually cannot do non-nullability, but the server can do it already. So with this exclamation mark, I'm now telling my GraphQL server that I'm not accepting null for this field. And what would happen now is actually that I get an error here, and then everything is nulled out until nodes, because nodes is nullable. But I could also say, okay, this is all nullable, all non-nullable, and then everything would be deleted, and that's actually not what I want, but just to make the point here. So we could now isolate this and actually shape this a bit different and say maybe this guy here, nodes, should be nullable for the elements, but non-nullable for the list. And then we can execute that again. And then we get all the items, but we just null out the item that is not abiding to our non-nullability concerns. So what this feature actually gives us is the ability to set nullability in our client to our expectations, and then let this expectation be fulfilled by the server. That means I have to write fewer null checks in the client, have nicer generated code, and can even do things like that and filter out things that don't fit to my expectation. In this case, the client would just go over, filter all the nulls out, and the rest of the component data is valid. Okay, so there are a couple of other proposals we are working on. And there's, for instance, struct. That's something Benjie is very excited about. It's about a new data shape, or new, you could say, improved input types that could also be used at output types. There is like a metadata approach we are working on. Metadata is a better way to introspect, like if you did introspection and wondered that you couldn't introspect actually type system directives, it's a major hurdle for dynamic applications, no-code, low-code solutions. But with metadata, we would enable you to introspect these types over your type system. There's also one-off. One-off is this thing that is around for a long time. It formalizes the tagged union pattern. The tagged union pattern is essentially a structural input union. So we can finally do input polymorphism. And one-off actually is almost finished. We also have that already implemented in our server. But it's still waiting for final approval. There's a new specified by and feature flags. And feature flags is something I'm personally very looking forward to. So you can see there's a lot more coming in GraphQL. So I would say if I look at the feature set that we are working on, GraphQL is taking its biggest steps, evolution steps yet. And there is a lot things you should get excited about. But as with many things, it's not the big splash. If you think about or reflect on GraphQL as it appeared on the scene, it was like Facebook came out and said, okay, this is GraphQL, and it was like amazing. How did they do that? But actually, Facebook worked over 6 years on GraphQL before they open sourced it. And it was actually, if you look at their original REST APIs, incremental steps that they went through to get to GraphQL. So it was not like they came out with GraphQL and said, okay, we found the solution to all your problems. It was more they did these baby steps like we do nowadays. And if you do a lot of these baby steps, you will lead to a fundamental way you improve some technology. So I hope this gave you a bit of insights. I know it was a lot of abstract topics I talked about that we are, it is essentially a bit an insight into the discussions we do at the working group and the topics we are working on. And Deferred Stream is at the moment the main topic we are talking about. We are talking about this every week, once, with a lot of folks from Apollo, from our company. There is from First Dibs, like Rob, he was here at the last meetup, and Benjie. So a lot of these folks are putting a lot of energy into this. So, and I think this is if you look from a feature perspective, it's the next subscription feature. And it will put a lot of the guardrails in to, at some point, also go to live queries, which I would also like to see in my lifetime. With that, I'm done. If you have questions, go
Thank
ahead.
you. Great talk. Thanks a lot. It's really nice to see that so much is going on. Like, a year ago, I was thinking that nothing is changing in GraphQL actually,
Yeah.
and it's not going to change. But then you have all of these amazing features, so I cannot wait to see that implemented. Like it's really crazy that it's already working somewhere in some servers.
Yeah.
Yeah, crazy. Do we have any questions?
Just for this non-null propagation, it's like in TypeScript when you use exclamation mark, it is like a non-null assertion.
Yeah.
And also the question mark is non-null. The question mark is also for like being able to go deep. The semantics are different. It's like intentional. It wouldn't be confusing that, you know, in TypeScript I would say exclamation mark to the compiler, trust me, this is not null. But in GraphQL it would mean if it is null, then throw an error on me. Or
yeah, it kind of is an assertion if you think about it. We are asserting it's not null, but when the assertion is false, we are propagating.
yeah,
And that's why I like more the error boundary explanation. Like you have error boundaries, for instance, in React. It's more like that, where you throw at some point and then you catch it at some other level.
yeah, but TypeScript doesn't really catch it, likes it, like it's like a hint to compiler because compiler cannot narrow the type enough. Yeah, I think it's a bit confusing that they're using the same operators that TypeScript is using, a slightly different meaning, but that's fine. And for the stream and defer, when you want to use them, do you also need to use the fragments? The fragments are a way of like labeling the stream or defer?
Yeah, there are so. It depends from where you're coming. Like, I have a strong relay background. That means, so I actually have no clue about relay. But my front-end devs are all relay developers. That's why they made me think relay. So that's what I mean with a strong relay background. So in relay, we think about componentizing things. So you always think about these fragments. One fragment essentially is a data contract or the input into your component. And that's a way of how Facebook thinks about client development. And suddenly with defer and stream, it's important to know when the data for your component is there so you can render that component. And if we talk about merging fields or even skipping defers that you as a developer, as a client developer defined, we need to figure out on the client side if the data is arrived. Let me give you maybe a simple example here, because like a client component, where we see here asset info, for instance, is a fragment on asset. And here we also have a component on asset. And they could even have the same data. Like when we think about field merging, we say this is actually deferred, but now the GraphQL compiler or the GraphQL execution engine looks at this and says, okay, I don't want to send the same data twice. And actually we know you have the name field already there. So when I send you this payload, because this is not deferred, then you already have name, so I can go and just strike that out.
Yeah, but
it
would
could
it
be the other way
But
around.
if one part is deferred and another is not deferred, wouldn't it be better if defer like degrades to non-defer?
Degrades to non-deferred. How do you mean that?
If it's like one part of the query, like if you are requesting the same thing twice and one part is deferred and another is not deferred, then they should be non-deferred.
Yes. So that's what's happening here, right? I'm sending you the data now immediately.
Yes.
So what I mean is, so how do you check in the client component that your data is arrived? So if you, for instance, checked, okay, if name is there, then my data must be there because I also asked here for name. Or do you have an equals on all the fields that are in your component? And that's where this fragment indicator or this hack came from, where we could say, okay, maybe we just repeat here the fragment name and then we alias this, and this is our marker to know that this particular data has really arrived. Because when we find this field in one of the payloads, we know that this piece of information is there.
Wouldn't be the has next, there is like this, that there has more data on the response from the server?
Yeah, but it doesn't tell you which component.
Which part arrived, okay.
That is the thing. You need to figure out which part is there. Another, you have an indicator. That's one thing. So we tried with labels. So this is the iteration that we talked about, I think, in December that I have here. So there we have still the label. That was the first idea to do it. But when we now skip these differs, you don't have the label anymore. So if the server optimizes and kicks this defer out because we detected that you wrote too many differs or it leads to these 3,000 patches that I sent you, then the server just goes, okay, this defer doesn't exist for me because it's actually not a good defer. Then you don't get the label anymore. And then you need an indicator like this, or you introduce something where we essentially mark this with a real component. S is not a good name. So you know, when I actually started as a software engineer, little anecdote here, I was building a component that was called the assembly loader, and I wanted to shorten it, so I called it the S loader, but I didn't reflect what it actually means, and then we shipped it to the customer. And in the documentation it said, okay, use the S loader to... Okay, you learn.
Thank you. Any other questions?
Do I get a second t-shirt or not? Wow. Fine, I will still ask it. Okay, so this is not the first time I see the example. So first of all, I don't know much about stream and defer. I haven't read anything. Sorry. And this is several times I've already seen examples of this, you know, a feature presented in the context of lists. And the motivation is to improve the performance on front end, right? Because you can start rendering something. But as a front end developer, I think about it, well, okay, so I received some of this data. If I will start updating every single, you know, slot of the product or whatever, the line, I'm gonna create a lot of layout crashing, you know, there's gonna be a lot of updates and my browser will start freezing because I'm doing too much work. So then there's two questions. So I don't know if the user gonna scroll or is gonna start filtering. So I would expect that I would receive some data that I need, and then I would say if I need other data, like lazy loading. I start scrolling, and then I kind of actually start asking for more data. And the other thing is that possibly another strategy that I might employ is that I would load the images for the above the fold, like 8 items, but I would like to know how many items are there so I can put them in the DOM without the data, like placeholders. So I know in advance it's going to be, you know, 53 items. I would only receive data for the first above default 10 items. So it's all kind of like in CSS structured, and as a user starts scrolling, I can fill in. So I'm just wondering, is that something?
That are very good source, and they're all true. For instance, if we look at this example here, right? As I said, it's not about like endless list here. For instance, we have here the 3 most sought for cryptocurrencies. So when the page is loaded, we get this element here first. But we also deferred other things, like you can see components down here. This component is deferred, and also this component is deferred as one thing. Not the items, but the block. And we use suspense here, so we also use ordered suspense. So meaning because we don't know when the data is arriving, when this data, for instance, the loser's data is arriving before the gainer's data, we actually don't start rendering because we don't want to have these not so nice flipping UI elements. So you have to think about where it makes sense. For instance, this list up here, does it make sense to defer or to stream the items? No, it doesn't, because that is my ticker. So either I get all of the items in my ticker or none. Or maybe it could make sense that you say, I want the initial 5 items, and then it just starts scrolling when new items come in. Could also be. It is very specific to your application where this makes sense. And now I think we decided, okay, we want the ticker completely. Here we need just the first graph. And then also this is as a whole deferred. And also this is as a whole deferred. So we get these blocks as they appear. The coolest thing in the server, we are doing a context branch. So they are now processed in parallel and then really sent down. The same goes really for this kind of data. Look, it doesn't make sense to, for instance, defer here the weak data because I never know if my user clicks on them. So we actually load them as it appears. So in this instance, it was in the cache. But if I click here on the months, you can see we are getting it now. So it is really dependent on your application logic. Don't overuse it. Not every list needs to be streamed, or not every block needs to defer it. And it also makes no sense here, for instance, to maybe defer this graph or so, because if I defer the whole graph, the UI doesn't make sense anymore, because just having here the number immediately, does it make sense for my UI? No. And this data below is very quickly there. So this UI, or this screen here, has no defer at all in. So it is, use it in the things where it makes sense. Also, like the example that you set with lists is, for instance, here we use infinite scrolling here, so I can now, it does a scroll call every time the data comes. We are not using streaming here, makes no sense, because I never know if I go down there. But for complex UIs where you have multiple components, maybe the first row of components, you see immediately no defer, but lower level components could be deferred. So there are a lot of use cases for it, but don't overuse it.
Thank you.
Wouldn't be like now React would have soon, maybe not, I don't know how when, but it would have server-side components.
Server-side components, yes.
They could probably address some of that as well, where you could make multiple queries and then chunk the HTML back to the browser. Yep. And then you could have your main graph executed first and everything would follow through.
Yeah, it depends. It depends all on your use case. So depending if you have a business application, for instance, server-side rendering can be a solution.
Yeah,
but
this is going to compete a bit like...
I don't think it competes, it complements. So we see that in a lot of business applications we do, that it actually complements. This application here is written with Next.js, so we're using at some parts server-side rendering, and at some parts more direct GraphQL. I think it complements.
More options, basically.
Yeah, it's more like this is your tool set. Use whatever makes sense for your screen. Like a content management system, maybe like a lot of very content-heavy pages where you have blocks and stuff, makes sense to render them with server-side components. But it's complementary.
Okay, thank you.
Thanks a lot. Any other questions? Yeah, we have two, so let's...
Hi, in terms of like a streaming, I see that you might do it somehow manually. For example, if you go to the first page of your application, yes. I clearly see something like an islands of this architecture. So maybe it would not be wise to use just one query to fetch all the data. Maybe it would be better to split it to several queries, like the one that will fetch data for the top of your application, then another query for your graph, and then another query for the data that is below. So thanks to that, once any query will be resolved, then you may render the part of your application faster. So how do you think about this approach? Is it better to divide to several queries or do the one only?
So the initial approach for different stream from Facebook, I don't know if anybody remembers, it was something they called batch with export. So essentially, it's very similar. You split your queries. But that means you need to maybe aggregate data on the client side. So the very nice example from Facebook was they essentially have a list of news that they fetch, and then they have to collect the IDs from that and then feed it into the comments to fetch the comments for the news. So now you're dealing with these aggregations that we had in the REST side again. And instead of just telling the server, and maybe the server has a much more efficient way to branch off these connections. So while this is a solution that you could use, it might not be the most efficient way. So it's more efficient to write one query, one logical query in your mind, and then let the server sort out how to efficiently get that data. That's the explanation. And the second thing is you have one HTTP post request that you can stream over. So very, very efficient also network-wise.
Okay, thank you.
Thanks for the question, and we had another one here.
Okay, so that wasn't in the presentation, but I'm a little catch on that future flags. Can you like a little more talk about it? Like on what kind of level that future flags will be?
So the idea is, I don't know if it was Yelp or Twitter, but one of these companies, could also be GitHub, had a case where they have like experimental features in the graph. And the problem is once you put something in your graph, you essentially have it there. And the main idea was then to have a feature flag to essentially mark parts of your graph, mark parts of your type system as kind of we're trying something out. And the idea is that you can then, or the evolving, it's still a very early discussion on that, is maybe that you can opt into versions of your graph. And I don't mean versions in the sense of REST, like I want to opt into these features and suddenly you have the types available to you. Or I opt into multiple of these features, multiple of these feature flags you set on, and then you have available these types. But your standard applications just get your graph as is. So that's essentially the premises of this. And the idea was to more generalize it. The first idea was very simplistic. And now it's worked on to be more generalized so that you have essentially flags where you can mark sections of your graph. But as I said, that these features sometimes start out one way and then change also shape. It's the same thing here. Like for instance, one-off started as a very simplistic thing to codify a behavior that already was there. So tagged union, anybody knows what a tagged union is? Say that? So a tagged union or a structural union is essentially an input type that we use, where each of these fields represents one case, one of our polymorphic cases, one type case. And that's something that, for instance, gRPC uses. And in GraphQL, people try to model that. So we started with one-off, and one-off is almost ready. I need to push Benjie to really get the last thing on it. But then the discussion evolved actually in something like struct, like a more powerful way to have input polymorphism. That's why I'm saying like feature flags also is like evolving. So
I get it now. Okay, thank you.
So sorry, maybe this sounds like nitpicking, or but so I really liked your answer actually about the thing, because I received recently a question on GitHub, you know, about using the different stream if we're planning to edit and for the list, and I think what you said is like it not always makes sense to use it. But then here's another question: Is it maybe could evolve into kind of like a bit of an anti-pattern here, like of people abusing this feature? And one of the things that came to my mind right now is that essentially having this pattern is so convenient, then you stop doing caching, and because you stop doing caching. Now, seeing all these requests, the compression algorithm is probably not as good, because now instead of having one big compressed chunk that can be reduced in size, I have a lot of small chunks that are not as efficient in compression terms, right? So the amount of kilobytes now is inflating.
Yeah.
And so me as a developer is like, yeah, I would not do caching so that give you the response quicker and more compressed and more efficient. I'll just give you one by one and a bigger payload,
So yeah, so these concerns are good concerns. Actually, we are talking about. That's what I said when we got into the discussions, or the last things we are working on, the last big issues we are working on, is all about efficiency. Like we want to have this to not deduplicate a lot of data, so that we have essentially the same efficiency as, almost the same efficiency than you have when you would fetch it in one go. And that's why we are talking so much about field merging and also dropping differs in places where they make no sense. And the other thing here is sometimes it's worth sacrificing some bytes for speed. So it's always memory or speed, right? You can have a lot of caching, but then you're using a lot of memory on your client side. But you're sacrificing this memory to gain speed. So sometimes it's worth to sacrifice something. And in this case, I would say, again, every feature can be used as an anti-pattern. So you could say, now I'm actually predicting what the user will click, so I'm always preloading all the stuff that I'm never going to use, and then you're clearly using it the wrong way. But yeah, so use it where it makes sense. And again, we identified a couple of things also in applications that we implemented, so we are using that actually in production. And there is, like, for instance, for a Swiss company we are working for, they are using it for where they load the contracts, and there are parts of the data they calculate which are very heavy. But the user will look at them, but not immediately, has it not in view immediately. And now it appears on this page as if the data is instantly there, and that's the effect you want to do. But you will still pay the same price as before. Like, you're not making your data come faster, you just have the effect that the user can immediately interact with your application. And that's where this feature fits in. So.
Yeah, I want to add to that. I think that's where I started with asking about lists, because I think lists are, maybe not the best use case. And one of the things that we had in mind using Defer was, when you get a basket and, you get the total, the price and of the items, and we have this external webhooks where you're figuring out what the price of shipping is. It's just one of the fields that might take, we give up to 15 seconds for you to figure out what is the price of the shipping, but we want to render the response as quick as possible. So basically, relying on these external APIs, we can, just give you the information that you care about, and the shipping would, arrive later, and that later might be later. But instead of, freezing the whole checkout and like waiting for 15 seconds until, we know what is the price of the shipping, we can show you something. And like these use cases are very, very useful, especially in the like event-driven, where you have a lot of third parties that you rely on a lot of answers,
So my feelings, my gut feeling is anyway that Defer is what people will use the most. Stream is, you have to have a real good use case for it. But the thing I think will be actually most used is Defer, because it's also easy. You slap it on anywhere. It doesn't have to be a list. You just mark a section, doesn't make sense actually to do that here. But you just mark a section and say, this is expensive data. Give it when you're ready. And this is what I predict people will use a lot. And that's also the feedback that Apollo has from their customers. So they started also implementing parts of their solutions with defer. And this is what people are going to use. Stream, rare use cases. So your feeling about lists is quite spot on.
Thank you. Thanks. So I think we'll stop here because we are running out of time. I know Michael needs to go back to Warsaw today, but I hope you will stay here for at least an hour or so. So we still have some beers and drinks and stuff. So we can stay here and discuss in the kitchen. So thanks a lot for joining us today, and see you in April for next edition. Thank you.